Hi everyone, I'm Daniel McInnes and I'm the Shared Stewardship Coordinator with the U.S. Forest Service Southern Region out of our regional office in Atlanta. So shared stewardship is a strategy that integrates the agency's decision making with states and partners to achieve conservation and restoration outcomes at the landscape level. So as part of the agency's effort to steward the whole, the Forest Service helps convene the Keeping Forest Partnership. Keeping Forest is the Southern Region's high priority working forest conservation initiative that's supported by around 40 partners from across the forestry community. So forests really are our planet's hardest workers, right? They help drive our economy here in the South. They positively impact the physical and the psychological health of our communities. They help filter our precious water and air. They provide abundant habitat for wildlife, and they offer just a wealth of recreation opportunities. Over 110 million people and growing call the South home and depend upon the benefits that the roughly 245 million acres of forest land in the South provide. So we're incredibly fortunate in the Southern region to have a long history of landscape level assessments related to forests. It dates all the way back to the late 60s. These assessments look at how land use is changing and also the condition of our forests. The most recent assessment, which was developed by the U.S. Forest Service and the Southern Group of State Foresters, is the Southern Forest Futures Project, which was published in 2012. So the Futures Report forecast that we could lose up to 23 million acres of forest land to development by 2060. So Keeping Forest was started to address this potential loss of forest land, and the approach to conservation is radically different than the traditional approaches. So partners within the initiative, are a diverse range and include NGOs, industry, private landowners, federal, state, and local governments, water utilities, among others, but we all have a common mission, right? And that's to ensure that in 2060, we still have at least 245 million acres of forest land in the region. We're focused on systems level change using a collective impact model. And one of the best options for conserving forest land in the South, we believe, is to provide markets for private forest landowners because they own 86% of the forests in the region, right? So that's why Keeping Forest is presenting this webinar series on forest products. The partnership is looking for ways to expand the use of products from southern forests, going beyond consumer goods to include construction technologies and other things. And that's really so that private landowners can achieve their management objectives. They have the economic incentive to achieve those management objectives and to keep their lands in forests. So thank you for joining. And before we move on to our topic of the day, let's hear from a few of our Keeping Forest partners.
Hello, I'm John Mulcahy, Vice President of Stewardship at Georgia Pacific. Here at GP, we believe that the role of business and society is to help people to improve their lives. We do that by using forest products to create solutions that help people improve their lives by creating shelter, improving hygiene, offering convenience, extending shelf life, and protecting goods in transit. It's important for us to be good stewards of the natural environment and ensure that forests remain healthy and abundant in perpetuity. That's why we work with organizations like Keeping Forests, and we share their commitment to create the conditions that will help forests to grow, working with the landowners, ensuring that they have incentives to take care of their land and to replant after harvest.
Good afternoon, everyone. My name is Sam Cook. I'm here at NC State in the College of Natural Resources. I serve as the Executive Director of Forest Assets and our Vice President of the Natural Resources Foundation. We work to develop leaders and solutions for challenges impacting the environment, economy, and society. Our Sustainability Office was established in April of 2008 to serve as a centralized resource of sustainability information and action for our students, faculty, and staff. The mission is equipping the NC State community for a leaner, smarter, stronger future. Our vision is a cultural that creates leaders and sustainable solutions for global challenges. How does this fit into the mission of Keeping Forests? Since I explained earlier, we at Keeping Forests are a diverse coalition conserving the natural, economic, and cultural values of responsible managed southern forests. Through the power of collaboration, we are redefining the challenges of forest conservation in new, and compelling ways. I feel like this mission that Keeping Forests has provided is allowing us to be partners here at NC State in the outcome, because we can join together to make sure that this solution come true by 2060. Thank you for your time.
I'm Brian Dangler, Senior Vice President for the Conservation Fund's Working Forest Fund program. For the past 37 years, the Conservation Fund has been the leader in protecting America's working forests, lands, waters, and special places. As the nation's only conservation organization with a dual charter for both land and water conservation as well as compatible economic development, our work has always been about the conscious effort to include people in nature. That is how we at the Conservation Fund define sustainability. Can we conserve nature and society at the same time? Our Working Forest Fund program is specifically designed to permanently protect America's privately held large working forests. These lands have been assembled by the vertically integrated forest products companies over a century, and they're rapidly being sold off into smaller and smaller pieces. And eventually they will be developed, changed into different land uses. We've conserved about 1 million acres so far. We have a goal of conserving another 5 million in 10 years. We think permanently protecting large working forests for all the co-benefits they provide society is our nation's most urgent conservation priority. And it fits perfectly into the mission of the Keeping Forests Initiative.
So now I'd like to welcome Bruce Lindsay, who is our speaker and presenter today. And just a reminder that you need to finish the portal process when you want to get continuing education credits, and that you can ask questions in the Q&A at any time. All right, Bruce, I'll hand it over to you.
All right, thank you, Leslie. I appreciate it. And thank you to Rick, Zach, everybody. Appreciate the invite. Always happy to speak with the group here. Looks like we've got a great group today. It looks like almost 60. So thrilled at the turnout. Got a great topic today. I'm going to try to dig into some of this, but quickly, I want to introduce, I think most of you know who WoodWorks is. Let me go ahead and get my screen shared here. Hopefully, Leslie, you'll let me know if something's not working right, but hopefully everything's working there.
Looks good.
All right, thank you. I appreciate it. All right, so WoodWorks is basically an industry resource. Started about 15 years ago based off a Canadian model. And the goal was really to grow the market in the commercial sector. Obviously, single families always used wood, and by all indications always will. But we definitely saw in the market a drop as we hit the recession in 07, 08 area. And we knew that the questions were coming in as an industry, and we just didn't have the resources out there. Most of the retail yards were really set up for single family. Commercial is a totally different animal, has different building codes, different needs altogether, different distribution, different general contractors. It's just a whole level beyond what our industry was really set up for. So WoodWorks was set up as this free support, project support, education, and resources to try and develop that market. It started as a pilot program for about 3 years, and then ultimately turned into what it is today. So it's basically nationwide support to help the architecture and industry side of it. Now, we have expanded that. We are now working to train general contractors, particularly in the mass timber era arena, because that's something fairly new and there's really nobody out there doing that. And now we've actually started reaching out to developers because ultimately they're the ones driving the decisions of whether or not they're going to use wood. The architects and the engineers can, we have historically given that to the architects and engineers to take it up to the developers, but all it took was one concern by the developer and that would change quickly. So we've learned to go from the top down, and we've started that in the last year, and personally I'm heading that up. So we're seeing some great success with that, but you can see some of the things we work on. And obviously it's not just me. There's almost a team of 40 at this point, working in a variety of roles. And we feel like we have some of the best experts in not only in the United States, but in the world as it relates to the use of wood in multifamily and commercial construction. So that's a little bit about us. And as I said, it's free project support. So obviously the funding has to come from somewhere. So the Southwood Lumber Board, USDA Forest Service, and Forestry Innovation Investment are funding partners. In addition, we also have our board partners, market development partners, and industry advantage partners. So I do want to take a moment and thank everyone for their support and enabling us to do what we do to grow the market for our industry. All right, so we're going to talk today about basically educational buildings. What does it mean within our industry? What are we looking at? What's the potential? Where is it going? I'm not going to read through this. I think everybody kind of got a snapshot of what we're going to talk about today. But just to tell you what the impact could be. So this is 2019 data. Now, often, and I know for me, when we say $98 billion, it's a number to me. It really doesn't sink in. But if we look at the total construction costs in 2019 related to educational facilities at $98 billion, keep in mind that includes new construction, renovations, and site work. So not exactly just the cost of the building, and a lot of it may be renovations, but here's what is important, and this is what is relevant to our industry. Of the square footage, so 425 million square feet of construction overall in the non-residential sector, single family is what we're saying here, in the 1 to 6 story range. Basically, almost a fourth of that is in the educational sector. So that's a huge portion of the construction industry, and it's something that, as an industry, we really haven't capitalized on yet. And we see that as a market potential for growth and something that we're aggressively pursuing. But as you can imagine, it's a difficult challenge and a difficult pursuit. But looking forward, a lot of this, most of us, I saw a few, I think one from Arizona all the way up to Pennsylvania, but just about in all of the sectors for the attendees, we know that our population increase due to movement within the United States is increasing well beyond 4%. I think I live in Charlotte, North Carolina, and forgive me, I really didn't introduce myself and my background. So I worked for Weyerhaeuser for about 15 years. I've been with this group for about 15 years. I have backgrounds in architecture and engineering design and a variety of other things. So I'm a jack of all trades, master of none is the way I like to put it. But I live here in Charlotte, and the one thing we've seen here in Charlotte, and I know this is universal throughout much of the Southeast, is we literally in the Charlotte area get 140 people a day moving. And part of what our early presentation was there, the introduction was the loss of forest land and really what all this program's about. And as we get more urban living, we're going to lose more of that to development. I know I can go right down the road here at my house within a mile, and I see 3 multifamily projects popping up. And that's just the reality of everybody has to live somewhere. And when we have that, then we also have the increase in the number of children and young adults that need education. And so what we are seeing, and this is by 2027, so 5 years from now, nationally, we're looking at, roughly, K through 8, we're looking at 4%. And then 9 through 12, we're looking at a 3% increase. Now, that's kind of strange because it tells me that maybe we lost somebody somewhere. But I think what we're going to see overall in our regions is that that's actually more. And that's important because, there's geographic isolation as we look at products and where they come from. So I think it's in everybody's best interest that we actively go after school projects and keep this going. So there's great growth potential here, and we're seeing that. And then when we start looking at the size of these projects, now this is square footage and the number of stories. So if we look, the number of stories is across the bottom here. So single story, 2-story, 3-story. So we see that the most prominent is 2-story educational buildings at roughly 48,000 square feet. And that kind of makes sense. Now, the reality of this is basically that's not that big of a building when we talk about commercial construction. And this is from 2019 construction data, but that really, we don't expect that to change. They might get a little bigger, but you're not talking about a big change. What this means is basically we don't need anything extreme within the code to build wood projects in the educational sector. Now, you get into university academics, you may see something a little taller, but for the most part, we're talking about something that's easy to do. The reality is, and as we face the inflation factors we're seeing every day in the news now, we have to cut costs because what we're seeing from any school district is that they simply don't have the funding, whether it comes from the state A lot of it comes from the local tax base. There's no way they can catch up. They get all of these extra kids and you get the population growth, but the tax base is always lagging behind. And a lot of times it takes bonds and other things. So there's always this lag. Now, this is cost per square foot. Now, you'll see that this is divided into two sections. So there are, across the bottom, you'll see 5 different construction types. Now, within the building code, without digging too deep, there's 5 different construction types. Now, there's an A and a B. The A has more fire protection in it, so it's more costly, but it may not need fires, have fire sprinklers. There's a variety of factors. We're not going to dig into that. But what's in blue, type 1 and type 2 construction, is what is considered non-combustible construction. So that is not typically using wood within the construction type. And you'll notice the cost per square foot. Now, this is just the cost of the structure itself. This does not include the land purchase, civil, things of that nature. It's just the structure. So you can see if you're using type 1 and type 2, which does not allow the use of wood, you're talking about an expensive building. Now, type 1 buildings are, a stadium, a skyscraper. These are unlimited scale buildings. If you go to the far right, where we've got type 3 and type 5, this is where combustible materials are used. So these fit into wood quite well, and you'll notice that the cost goes down. With that, if you go to type 5, you're not allowed to go to an overly large building. You can't build a stadium out of wood, not because structurally we can't do it, because there's other factors within the code as it relates to egress, safety, things of that nature, that we can't do it. So the goal here is to really show the architects and engineers how to build with type 3 and type 5 construction. And as I mentioned, these are 2-story buildings averaging 48,000 square feet. They easily fit into these 2 subcategories of construction type where that can be done. Now, keep in mind, that's 2019 data. We look at those prices. So when we start comparing these, and we look at the average size of an elementary school or middle school, high school, and so on, what you're going to see is the potential savings per square foot. Now, again, the cost per square foot is relevant to the time at which it was taken. This comes from 2020 ICC. Now, ICC is the International Code Council. They're the ones that develop the International Building Code. The numbers we're looking at is a summary of the average building cost. They pull this together twice a year, and this is what a municipality looks at when they look at permit costs based on what type of construction it is, what type of occupancy, which in this case is educational, and that's where this price comes from. So it's fairly accurate, but it does represent nationally what the cost would be. So if you're looking at the average size school, you can see by using type 4 or type 3 and 5 construction with wood, you can see that we're talking millions of dollars in savings. And this is critically important when we start talking about, where does wood fit into these schools and what is the draw if you're on that school board or you're a facility director to go with wood, something that typically has not been used in what I'll say large scale educational facilities. So here's an example. So Fountain Lake Middle School in Hot Springs. If you look at that, it's traditional framing, sheathing, the initial steel and masonry estimates, which I'll dare to say most of us probably went to a building or to a school that the building was composed of probably CMU and then steel of some kind for the roof system. You can see that over the entirety of the project, there was $2 million in savings. Here's another one. An elementary school, 71,000 square feet. And again, you see about $10 per square foot savings in the structure when compared to other building materials. Newport Elementary School. Now this is older. Look at 2010, larger one, 124,000 square feet. Now I want to point out, if you look here, I think my pointer's showing up on the screen for everybody. You'll see some steel. Now this is what we would call a steel moment frame. So basically when the wind blows right to left or left to right, we have to brace the building somehow to keep it from racking. And so a lot of times we'll see steel incorporated into that. And that's just a structural necessity depending on where it's at. So if you're near the coast, you're going to have high winds. If you're in a seismic area, we're going to have to deal with seismic loads. So sometimes you'll see that incorporated, but the reality is there's still a whole lot of wood in this project. And it's allowing us to do a lot of things that we couldn't do before. So it is common to see a lot of hybrid projects. But on this particular project, The savings were $30 a square foot. And according to the architect, $20 per square foot of that was attributed to the wood construction. So it is quite feasible. We've seen it. We know that there's great savings to be done with that. The El Dorado High School is probably one of the best examples, and you're going to see me reference it a lot today when we look at it. And as you look at it, you can tell it looks like any other school building. There's no way you would really know that it's wood, constructed from the outside. It has all the durability and the beauty of any other project. And that's really the goal here, is that you don't have to differ to have the efficiency and the sustainability of wood construction in these buildings. And this is a large project. You're talking about 1,600 student capacity, over 300,000 square feet in total area. Now, again, this was built about a decade ago. So you're looking at a $43 million construction cost, which is unheard of at this point with cost now. But the construction cost was within the realm of all other building materials. So it was $134 a square foot for construction. And that was very reasonable and very efficient. And it's a great project. And when we talk about this particular project, when they talked about the framing, the architects looked at it, they saved $2.5 million plus. So 5% of the original $60 million budget. And that's huge to a project when we're looking at cost. And this is going to become more important. Now, I showed you this before. This is the cost per square foot for an educational building, what we call an E occupancy. And the occupancies vary. So you could have a residential occupancy for a multifamily. You could have E for educational. There's mercantile. So these are broken down and they're fairly accurate when ICC does their valuation data twice a year. So this was the cost in 2020. This is the February 2020 data. So let's just focus on one. Let's look at type 3A, which is $175 a square foot. And let's look at now 2022. It's jumped to $216 a square foot. And if you were to go across all of those construction types, what you'll find is that averages out to an increase of 23% in construction cost just since February of 2020. This is nothing unfamiliar to any of us. I think we've all tried to do some home projects lately and you kind of get that sticker shock. And we all know within the news what that means as far as new construction. It's been a great era for us in the wood industry, but there is a trade-off because it does slow down construction to some degree because of the high cost. Now, what this means for schools is that, again, now if you're looking to build a project, you've got to add almost 23 to probably 25% by the time it's all said and done, just for the increased cost of materials. So more than ever, if you can save any money in the project, it's going to be critically important. What are we talking about in the school? We've got various spaces, and with the complexity of the school systems now and of the curriculum, it will change drastically. So if we're talking about an elementary school, basic school, and this looks like, you know, any given school. The classroom can be smaller, particularly with elementary or preschool. The facilities are simple, easy. It's usually a hallway with classrooms on either side. The spans aren't very big, classroom wings. But if we start getting into higher education, high school and above, we're looking at things such as labs, which have a larger space, libraries, which again, you could probably put some columns in, but you really want that appeal and the ability to store heavy materials such as books. Cafeteria, which usually needs larger spans. Now, you'll notice there's columns in there and you can integrate the columns, but every time you put a column in, it interrupts things. So the goal from a design standpoint is to minimize the number of columns in an area where you have gatherings such as this. And then ultimately, the biggest span we see when we look at academic buildings or educational buildings is that gymnasium or that arena area. And these are large spans, and that's more difficult. One of the challenges and one of the I'll say misconceptions about using wood in educational buildings is the durability. Now, we've all went to school, we all had seen in our lifetime at some point, somebody damaged, carved, cut, vandalized. And the general perception from the public and from particularly from facility maintenance directors is that wood is not durable. And one of the biggest things, just something as simple as, a library cart going down the hallway, and if it's just sheetrock, it's going to gouge into it if it hits it. If you've got 1,000 students and they're changing classes every hour and a half, book bags, banging into it, leaning on it, graffiti, writing, handprints, you name it. Gypsum is not always the answer, and that seems to be the more typical way to do it. One of the ways to avoid those penetrations through there is to simply put a wood structural panel behind it. Very cost effective, very simple, and from a structural standpoint, it makes the building much more rigid and can give it what we call shear walls, which eliminates the building from racking, and many times are actually required to get the structural capacity out of the building. So there are ways to do it, and we have to be smart about it. When we talk about how to put wood into a building, particularly a public facility, you have to keep in mind what the user is going to be. Now, this is a great project up in Durham, North Carolina. It's private schools, Duke Lower Middle School. Notice that the wood on the columns here comes all the way down to the ground. Now, that same example, library cart goes by. What are the chances it's going to nick that and damage it? Probably pretty good. This is a private school, and actually when I toured it with a group of architects, I always joke, I don't know if they drugged the kids because they were the quietest, most reserved kids I've ever seen in my life. If this was a public school, it's likely to be a little different element. The first thing that's going to happen, you're going to get, a thumbtack put in here with some kind of note or a sign. You might get somebody's initials carved in it. So it depends on the application. For a public school, generally, when I talk to an architect, I generally say, I would not recommend this. And we've seen this, and that has to do with the durability. And there's ways to do it. So here is a wood frame school. And you can see that the wood frame walls had gypsum on it, but they've simply done something to avoid the damage to the wall. So it just simply has thin set tile on it, which gives a nice look. It's durable, it's vandal resistant. If you do break one, you have some unique situation, you simply replace that piece. So there are simple ways to give durability, and you'll notice the columns have brick around and there is wood underneath there. Here's a great example of durability. And when we talk about durability, durability is not only important from a facility management standpoint, but also from the longevity of the building. The reality of most projects, commercial projects in the world, is a lifespan of about 20 to 25 years. And it's not because the project is not structurally capable. It's more has to do with, is it something that the community as a whole sees valuable, particularly with schools? If it's ugly, if it's a maintenance nightmare and costs more to maintain, and we're seeing that with a lot of the universities right now. Some of the old historic dormitories, which were brick and mortar, horribly energy efficient. Actually cheaper to tear those down and build with modern construction than it is to try and retrofit those. So there's things out there. But one of the nice things about wood construction, particularly with heavy timber or mass timber, as we look forward, is the appeal. It's a beautiful building. And here's a great example. This is actually up in Pennsylvania. This building's over 100 years old. It was a hospital. Now it is a school that's home to over 3,000 students in grades 9 and 10. So it was an existing floor with planking. You can see the old building there that they've gone in, they've cleaned it up, and you can see that bottom right-hand picture. This was a beautiful, beautiful building. It's quite iconic in the area. And you can see the results. So for this intermediate high school in Pennsylvania, and again, this was back in 2010, they did almost 200,000 square feet of renovation and then added 122,000 square feet as an addition at a cost of $79 million. Now, keep in mind, 2010, that cost is likely doubled by this point, but there was huge savings in renovating that, and look at the beauty of that. And that's the reality of building something that has beauty and it has value to the community. They're going to tend to take care of it. And they're going to tend to want to keep it. And that relates to long-term investment. Here's a project in Texas. This is a school. It was built out of wood. Now, again, notice on the far right, you'll see that there's a steel structure there. And that's what we call a pre-engineered metal building. Basic warehouse. And then they've gone in and they filled in the floor system with wood. Very cost-effective way to do it. Not real attractive. And the reality is when this building gets to a certain lifespan, it looks like any other warehouse, and it's not likely to maintain itself with any value, although I don't know what the regionality of this was. It may be a school system that's remote, it's suffering from financial problems like every other one. This might have been the best resource they had. Compare that to this. more. It was $100 a square foot. But look at that compared to this. And the reality is, what is the longevity comparison? This is a beautiful building. There's a good chance that the community is going to embrace this building and see the beauty in it, and they're going to maintain it. They're going to want to keep it. So that investment, as you look over time, even though it costs roughly $30+ more a square foot, you've got something that's much more valuable and has much more longevity for a variety of reasons. And it's much more beautiful. Looking at those gym areas, we're talking, areas that are 7,000 square foot, give or take, with ceiling heights that are over 20 feet. And the spans range from 60 to 300 feet. Now, most wood products don't span that far. We're talking about 2x, we're talking about trusses, I-joists, whatever it may be. But there's some limitations on what they can do. About 30 feet with trusses and I-joists. Obviously, about 20, give or take, with traditional lumber. Or we can do something like this, where you've got a heavy timber truss, what we call a bowstring truss, where it's bowed across the top, straight across the bottom, and then 2x for purlins in between, and then it's sheathed with traditional plywood or OSB. And the result of what you get is this, a beautiful building. It's got the durability that it needs, both from a structural and standpoint, but also from a community value standpoint. In this particular project, they saved $60,000 by changing that gym roof from steel to wood. So not only did they save money, they've also got a much better end result that's going to have value in the community for much, much longer. Here's this is at El Dorado High School. This is their auxiliary or practice gym. And you'll see large glue lambs, again, some glue lamb purlins to go across. A lot of that's for support and bracing. And then it has I-joist up above with wood structural panels for the sheeting. So very cost-effective way to do it. It's still a good-looking project. And you could paint that and do some other things if you want. You can do things with trusses. This is what we would call a pin truss. So the wood flanges, these are 2x on the top and bottom with steel tubing, equivalent to what you'd see maybe conduit, electrical conduit. It's kind of that look and feel. And then there's pins that hold it all together. These can make phenomenal spans, and they can displace steel bar joists quite easily. And you do get a much better looking product, as you can see here. And again, some potential for savings. Going back to that El Dorado project, here is the center public area. And you'll notice that they've used glue lamb. It is wood framing, but look to the right when it was completed, you'll see brick protecting the wood surface down low, but you still get this beautiful roof element using glue lambs to get that heavy timber concept across. And we see this in a lot of projects around the country, up in Minnesota, again, the public area. And now this is a type 2 building that is non-combustible, but if you are a certain height off of the floor, basically away from any fire potential, you're allowed to use wood in the roof. And that's a very cost-effective way to really upgrade the building and potentially save some money, particularly in those middle areas. Now, I'm going back to this Duke Lower Middle School. Now, look how they utilize wood in this one. Some areas it's down low to the ground, and it really had to do more with the superstructure there as we look at those arch supports. But if you start getting into the middle areas there, you'll notice that there's not a lot of wood exposed down below, but you get this beautiful, beautiful roof system with a lot of natural daylight and the beauty of wood. And that really influences the learning environment. And part of that goes back to what we call biophilia. So there has been studies done, University of British Columbia, Innovations, that were well in tune with. They had 4 environments here. So if you look at the very top right, it's a very basic environment. It's all white, commercialized. There's no natural anything there. If you go to the left, same thing with some plants. But if we kind of go down to the bottom right, then you will notice that they've incorporated those wood surfaces. And into the far left bottom, you'll see that they've actually kept the plants in here. And what they found, they did 3 periods. First, simply just waiting in the room, like you would in a doctor's office or anything else, quiet, waiting in the room. The second portion was taking an audio given math test, so a little bit of stress inducement. And then the third part, recovery after that. And so what they were monitoring was the sympathetic nervous system, heart rate and skin conductivity, which you tend to, have sweat and more conductivity with stress. And what they found is when you measured that stress, it was lower in a wood room in all periods of the study. And we've known this. The Japanese have done a lot of studies on this. The Canadians, you'll find a lot of their healthcare facilities incorporate wood. We know it to be an effective part of learning. And Duke Middle School, Lower Middle School is a great example of that, where the architect really tried to incorporate that environment and really keep it as a warm, welcoming, natural feel throughout the entirety of the building. And even as we start to move around and look at it, it's even carried over to the outside. So an absolutely beautiful project, very cost effective, and did its job. And as I go back to, it needs that wow factor for it to be something that appeals not only to the community, but to the students themselves. There's still an exceptionally high dropout rate in our public school systems. And now the challenge has gone beyond that. Now we have the challenge of keeping teachers. And that's really been the bigger challenge within the last 2 years through the pandemic. We all know that teacher pay is not the greatest in the world. And these are some of the most dedicated people you'll find. If they don't have a nice facility to go to, that just stacks on and adds on to that pile of grief that they deal with on a regular basis. So having a nice facility is so critical in so many ways, not only to the students, but for teacher longevity as well. Here's that high school up in Minnesota again, type 2 building, 270,000 square feet, where you get that warm appeal. And it's a more commercialized, what I call a more traditional commercialized look, but just that simple roof element really changes that. Here's that El Dorado High School gym once it was completed. Very modern looking, very appealing, yet still warm and inviting. Here's a more natural setting in Lakeville. A lot of daylight, a lot of exposed wood. Again, note it's up high where it can be protected. And then here's a very unique one. Now, this is not going to be a common school. This is in Vermont. It's one story. It's only 4,000 square feet, but it has won a wealth of awards based on the fact that it's a net zero building, very sustainable. It's won a LEED Platinum. I'll talk a little more about that. And notice how they use the tree trunks, basically as is, and incorporated it into the design. So very, very unique and beautiful building. So let's look at those. We've looked at these, and that's more of a traditional study of projects, what they look like. And again, these aren't always large buildings, 1 to 2 stories on average, very simple to do with common light framing, wood, lumber, I-joist trusses, things of that nature. But as we start looking at the future and more complex projects and something that appeals to the public, the teachers, the students, the community as a whole, we're starting to see something incorporated in, and it's something that we're all at this point familiar with. We're starting to see mass timber. In this particular case, you're seeing CLT and glulam. Notice the stairs over on the left, how they've utilized CLT for that. The roof system, you'll see it there. Large glulams. Again, see the stair system back in the background there. Another project up in Vancouver. Now, this one uses traditional glulams across the top. They do have a slight bow to them, but the walls are CLT turned up. Now, if we look back at that El Dorado High School, you'll notice and I think there might be another picture, you'll notice that the gym walls are concrete masonry, CMU block. Common to most educational facilities at that scale. There's reasons for that. One, you've got to have that lateral stability. If you think about all the mass up high for the roof system, you've got to be able to stabilize that in a 100+ mile-an-hour wind or in a seismic event. Reinforced concrete masonry can do that. And historically, that's what we've always done. But now that we have cross-laminated timber and we're starting to understand it, we've got the research and the documentation behind it, now we can start building these walls out of that. And this could actually go into the industrial side where we see a huge amount of growth right now. And we've got a lot of research and study going into that right now. Here's Franklin, West Virginia, smaller school, but they did their gymnasium out of that. Again, you'll see the vertical panels of CLT and on the roof, large glulams for the structural components. Another one in Washington, similar. Washington, D.C., that is. How about climate? Where does that fall into play with everything? Because it is an incentive, and we're seeing a great momentum within the industry based on climate change and what that means from the way we address it. So, obviously, what is it here? It's already 85 here in Charlotte. I think tomorrow we're supposed to break a record of high 90s. Whether or not that's global warming, that's arguable, but it's darn hot here, I can tell you that. We do know water levels are rising, so we've got a lot of challenges. And we know from our industry that wildfire is something that we're dealing with on a continual basis. It's challenging the USDA budget. It's taxing our firefighting capabilities and our forest management overall, because we're having to put so many resources into that. We know cities such as Miami and others are really struggling with the rising water table, ocean, I should say, not water table, which in turn causes other issues. So we know there's an impact here, and we're starting to feel it. And I think as a society, we're starting to embrace the concept. Yeah, we've got some challenges, and there's some great data behind that. I'm not looking to get into that discussion today. One thing we do know for a fact is that our carbon dioxide levels are the highest they've been in over 800,000 years. And if you look at the data for carbon dioxide levels within our atmosphere, based on emissions, basically since the industrial era in 1750, we're able to track this. And they can do this by taking ice cores from the poles, things of that, and measuring the CO2 level and knowing the age of it. And so what we're seeing is the highest levels we've ever seen in 800,000 years of CO2. And the concern is once we get past that 450 parts per million, it's a cycle that we cannot reverse as a society. And a lot of this is just simply based on the fact, the sun's always continually putting energy into the earth, and the earth over millions of years has taken this energy and converted it into basically fossil fuels and other factors. We've been burning that. And so you get this, when we look at the large time frame of millions of years to actually compact this energy into fossil fuel elements, and now we've burned it, basically in the last 200 years, we've released all this energy into the atmosphere, and associated with that, the carbon dioxide that goes with it. So it's no surprise based on that data that we're really experiencing a lot of global warming potential. And so it really breaks down to the chemistry. So everybody remembers the CO2 from elementary school. So a tree absorbs carbon dioxide, CO2, and then it releases the oxygen, the O2 portion, and it keeps the carbon. So as a tree takes in carbon dioxide and keeps that carbon, you got to remember that it's releasing the O2. So 1 ton of carbon in a tree does not equal 1 ton of carbon dioxide. It's actually a much better message. 1 ton of carbon stored in its elemental form in a tree or a wood product afterwards is the equivalent of 3.67 tons of CO2 taken out of the atmosphere. And this is nature's way of doing what it's done for millions of years throughout Earth's lifetime. And our industry plays a huge part in this. So where is the carbon stored? It's in all of our harvested wood products, our solid waste disposal sites. There's pools out there, and I say pool, I'm saying collectives, above ground biomass, below ground biomass, and there's a lot of other discussions we could have on that, so on down the line. But when you look at what the EPA studies show, harvested wood, above ground biomass, and things of that nature, there's a good number there. And this is something for our industry to be proud of. Obviously, we've got more work to do. But when we start looking at the carbon stored inside of a wood building, there are huge benefits that we're lowering that carbon footprint of that building because we're not using products to build it that actually produce more CO2. We're actually containing the CO2, sequestering it in the form of carbon. And as long as that building stands and that wood remains in in its form, you're storing the carbon dioxide in the form of carbon. So at this particular project in El Dorado, you can look at the amount of wood used, and that, again, these are numbers, but when you start getting down to the bottom, this is the equivalent of, in carbon dioxide emissions from fossil fuel, what you're capturing and storing in this building is equivalent to the CO2 output of 2,100 cars off the road for a year. Again, that's fossil fuel. We're not talking about electric cars. And then enough, again, fossil fuel energy to operate a home for 970 years. This is huge. And this is, if we can get all of our buildings to this point, this really drives a lot of things. And it really brings into question 2 things here. I need to kind of fly up here. We're moving a little slow. So embodied carbon is the carbon associated with the building product. So wood obviously is capturing that. Other products are not. They're creating it when we manufacture it. The operational carbon is what's in the building as you utilize it. So the energy usage to heat, cool, and so on. And so there's a great statement in wood because it doesn't transfer thermal energy like steel or concrete. It's self-insulating to some degree. It takes less insulation and it's more cost effective. A great example is in Washington State, the Bethel School District, where they've got wood projects for their schools. They save 4.3 million in utility costs, basically over a decade, less than a decade there. And that's huge. Again, and that comes back to more of that social sector of, where do we fit in and what are we doing for our part? If you look at that embodied energy versus operational energy, we're getting down to where the buildings are more efficient. And what we're looking at is that means that the embodied energy of the building elements become more important as we move forward in what we're designing out of. So there's credit systems out there, obviously. There's a wealth of them out there. They haven't always been historically favorable for wood, but we're starting to see some movement toward that. And as they start to become self-aware of what it means from a carbon sequestration standpoint, we're starting as an industry to gain some momentum and ground. And here's that same project. It's won multiple awards through LEED. And again, it's not a common project, absolutely beautiful project, but it's not common. And there's a lot of things there. So what's down the road for educational construction as we wind us up here? Well, this obviously isn't an educational building. This is the intro project in Cleveland. Now, this is a multifamily project, but it is mass timber. It's 9 stories with the bottom story is concrete, what we call a podium. And then the remaining 8 stories are cross-laminated timber and glulam. 500,000 square feet in Cleveland. And they're going to expose most of the ceilings, 50%, I would say. And then this is the big dog on the block. So this at the time is the tallest mass timber building in the world. This is the ASCENT project in Milwaukee, almost 500,000 square feet. Again, multifamily up on top. 25 stories, 19 of those are timber, over 6 stories of a concrete podium down below. And you'll see on the right, there's a reinforced concrete core for the lateral structure of the building. But, what does this have to do with school buildings? Well, as I said, we don't build that big, but if we look at mass timber as a whole, our group's been tracking this for some time. And the ones we know about, and we do this quarterly, at the end of March, there was over 1,300, almost 1,400 multifamily commercial and institutional projects that have been built with mass timber or a mix of heavy timber in the United States. And you can kind of get an idea of where they're being built. And you can see for the majority where everybody's at on this call, there are projects being built locally. And a lot of it just simply has to do with the building code. So the International Building Code is from the International Code Council. It's on a 3-year cycle. So all of this came around in the 2021 code cycle. That's going to allow us 3 new construction types. So I mentioned type 1, 2, 3, 4, and 5. We didn't talk about type 4, which to the far right has been what we call heavy timber. It only allowed us to go to 6 stories historically. With the introduction of the new technologies of mass timber, this has been added to the 2021 International Building Code. It allows us to go up to 18 stories and 270 square feet. And that's how the ASCENT project and others were built based on this code. Now, the reality is that these codes don't get adopted by the states for about 3 to 6 years because there's a lag as the states bring them in. So by 2024, most states should be utilizing this code, but there's always a lag depending on where you're at. The reality of what this means is that we know there's continual growth in mass timber as it starts to move forward. And you can see that curve is moving sharply north, and that's good. That's exactly what we want to see. And we expect more of that as the codes start to embrace it. And as we see the sustainable motivation from not only the government, which is probably going to start mandating some of this, but also from private industry. We're starting to hear about investors that want to meet their sustainable goals as well. And so they're telling these developers and the general contractors that you have to build to a sustainable level. And wood, as I've mentioned, plays a great story in that. And so CLT, as we start bringing it into mass timber in the schools, this is a project that that was on some of the emails going out. This is a 2-story project up in Franklin, West Virginia. It was built in 2015, so it's some time back. But this was the first CLT school in the U.S. They erected it in less than 3 months, and that's part of the story of mass timber. Is it goes up really quick, and there's some savings there. It's good to have the right general contractor that knows how to do that. But again, 2 stories, simplistic. There's that gymnasium we looked at earlier. There's some other projects. Now, if we start looking at more of the university level academics, this project up in British Columbia utilizes CLT for the stair system there. We don't have time to really dig in it today, but there's a lot of things you can see. And then for those of you down in Arkansas, the University of Arkansas built their student dorms with CLT and mass timber. And we've got a case study on that. Here's one of the highlights that we've got on our website, University of Massachusetts at Amherst. This is their design building. It's a 4-story project, 87,500 square feet, what we would call a Class A building. Absolutely beautiful, beautiful project. Really incorporating the wood and showing what you can do with it, not only from a beauty standpoint, but from a structural standpoint, utilizing mass timber in a variety of ways. And then in Clemson, the Andy Quattlebaum Outdoor Educational Center, which was completed, I believe it's been I can't tell time anymore. Like everybody else, the last 2 years were a blur. Probably 3 years now at this point. Beautiful project here in the Clemson area. There's obviously ways to go look at that. And that's turned out really well. And you can actually see that. That's on our website under it's won a variety of awards, including Wood Design Award. And so you can see that on our website if you'd like to look at it. And so this kind of brings us in full circle here. What's your role? Obviously our group with the Woodworks and Wood Products Council, we are trying to grow that, but we need everyone's help to do that from the industry. And we've talked about the ways to do that. And we really started reaching out to the general contractors because they don't understand mass timber, how to price it, how to erect it, you name it. So we've got the construction management program in place now. We've got a manual, we've got all of these different things behind the scenes. And we've got the U.S. Mass Timber Construction Manual that was released in October of last year. So this is a free download. You can go to our website and pull that down at your leisure. And then we have all of these. Now, these are just our regional directors. They're the ones out there at the front line. Depending on where you're at, feel free to reach out to any one of them or to me, and I'll get you in touch with them. But this is our project support field division. And their role is really to go out there and talk to the architects, the engineers, and so on down the line to provide that one-on-one resource. Now, it's not just architects and engineers. If you've got a project in your area, I know a lot of your industry leaders, I know you're also community leaders. And so when that conversation comes up about that school project, or maybe it's not even a school, maybe it's just your community building, you need a new fire department, you need a new city hall, ultimately, you can inspire that conversation to go with wood. Why not? And it's part of the theme of everything we've talked about today and within this whole program is keeping the forest. We have to ask for that because we know that the success of the forest is based on the demand for the forest. So I do encourage you, talk to them, pull us in when you need us. We'll be glad to help you in any way we can to do that. So that wraps it up for me. I think we're going to have some panel discussion here, Leslie.
Yeah, thanks so much, Bruce. That was a great presentation, and I loved all the pictures. I want to live in any of those places or go to school in any of those buildings. So we have a question here. What about considerations for noise and echo reduction or sound buffering?
Yeah, it's part of the design overall. So mass timber as a whole is a little more challenging because if you think about, I don't know if any of you play drums, but anytime you've got a lightweight membrane, we'll call it, and you tap it, it's going to resonate through. Now, wood is obviously not that thin, but it's very light. If we compared it to a concrete floor, it weighs 75% less. So the idea is if you've got a high heel and you tap it on that floor, the likelihood is that's going to transfer through. So we have to incorporate within the design ways to acoustically stop that sound energy through the floor, and then through the walls, we have to do the same thing. So that is part of the design. I wouldn't say it's something that can't be achieved, and it can be achieved very easily. And we've got all that data. So on our website for the architects and engineers, we have what they call the STC ratings, the sound transmission classifications, we have all of those details for the architects and the engineers so that they can pull that up and they can see how to achieve the code minimums for sound transfer and go above and beyond sound as needed. So that's a great question.
Right. We've got another question. What was the key to getting the El Dorado High School and gym project to use wood in construction?
I don't know the answer to that. I was not part of that conversation. We can certainly find out. I don't know that personally, though, I'm afraid.
It might be a good topic for another webinar. I think that's part of the gap too, is how to get to that point.
Some of the other projects,
Let's
Bruce,
see, hold on a
are
second
you
here.
aware of any
Okay, another
others?
question. Oh, no, wait, it's not a question. It's a statement about some.
While you're looking, Leslie, I had a question for Bruce.
Yeah, go
Some
for
of
it.
those other projects, is it cost that seems to be the driving factor, or is it biophilia? What are some of the reasons folks would choose wood in these community projects?
I would think it's a combination. Now, I think probably as we look forward and what we looked at from the cost structure, I think price is probably going to be a bigger motivator than most, and that's true in the construction industry as a whole. Everybody wants to build this grand project, and we've all done that. It's like, I'd love to have this house, but here's the reality of where I've got to live. And the same is true for any building. You know, these ornate projects cost ornate amounts of money. So the reality is you may not see the wood. And that's going to be a big motivator. Now, I think that's always the initial motivator, and that's true, like I said, in any construction or development cycle. But as I mentioned, the momentum for sustainability is going to be one that we already see growth in it. We're seeing a lot more conversation within the architects groups, within the mechanical and engineering groups. We expect it from government. I'm already hearing it from investors and we're talking about corporate investors that invest. Let's say you're building a $90 million multifamily project. There's investors that you typically never know or hear of. You might know the names of the companies, and they've got their checkpoints that they want to hit with their stockholders that say, you know, we want to hit our sustainable goals, and they've got those checkpoints. And what they're telling the developers is, you have to build a sustainably measured building for us to give you this money. So there is a huge amount of momentum coming from the environmental side and the sustainability side, which is a very easy statement for the wood industry to make when compared to others. And I think that's going to be the second big motivator, with momentum growing quickly.
Great.
Thank you. Let me follow up on that, please.
Okay.
One of the things we want participants to these webinars to do is to become activists, if you will, in their local communities, to ask for wood, ask for paper. And I believe I heard you say, get these folks locally interested, and then Woodworks can help out in terms of working with the architects, the planners, et cetera. Yeah,
and that's always a variety of things. And one of the things that our organization prides itself on is getting an answer. It may not be an answer that you like, but we're going to go out and we're going to find that answer. Now, we pride ourselves on having some of the best experts in the industry. We know a lot of the design teams, and we can incorporate those. The one thing we're very cautious of is we don't recommend one architect or engineer over another, or one manufacturer over another. We look to grow the industry as a whole, and so we don't show favoritism. So sometimes that puts us in a bit of a pickle of, well, who do you recommend? Well, we recommend everybody. What we try to do is, like, who do you typically use? Usually a school system, for example, has a facility director, and they tend to have architects that they've worked with in the past and they like to use. We can go educate that architectural firm and give them the tools they need to do that. And that's always a bit of a juggling act for us, but where there's a will, there's a way, and we're always proud to give it 110% effort to make that happen.
Great. And let's see, my last question would be, are there any grants or I guess just or tax cuts or anything for these types of buildings? Because I was thinking about it for, a public building or even a private building. Are there things that motivate them to be a trailblazer?
Yeah, I think so. So obviously there's some wood innovation grants that have been on an annual basis for the last few years. Those will be announced. This last cycle will be announced at the Architects Association National Conference. I think we had over 60 submittals this year, or right at 60. So great interest in that. And there's a variety of things like that throughout the year. And, you know, if you're within our industry, you see a lot of these here and there. Some of them are bigger, some of them are smaller, but I think it's incentive. And again, going back to that sustainable initiative that we're seeing from government, anywhere from the Biden administration on down, I think it's a reality that you're going to see some tax breaks potentially in the future. Now, a lot of that's driven by the local government, not so much at the federal level. Local government may participate in that. And, you know, as we look at what we do, we know that a lot of our industry is not in the urban areas. It's in a more remote area. And knowing what that means to the area as far as economics, I think there's a great statement to make of like, hey, this industry, the forest industry, propels this area. This is our financial backbone here. We need to support it with wood construction. And it goes back to what Rick was saying, that communication, it literally, all it takes is somebody to say, hey, have we thought about this? Because the path usually just goes, you know, this is the way we built it for, you know, the last 50 years. We just threw up a steel building and nobody's ever said, well, what if we try wood? I didn't think of that. So it's that simple sometimes.
So listening to you, Bruce, you know, anybody on this webinar, if they know they're going to have a new school or some public building built in their area, I think I'm hearing cost savings, the environmental accountability, the carbon issue, the speed of construction, the biophilia, and then what we're all interested in too is keeping forests and some of these local landowners who are managing their forests and giving us clean water, clean air, wildlife habitat, et cetera. Building with wood helps us on all of those fronts.
Yes.
Agreed.
Great. Well, it is the top of the hour, and I just want to say thanks again for presenting. This is an excellent presentation. I put in the chat box the next webinar in the series, the link to this. Also, if you're trying to get the CFEs when you leave this screen, please click onto the orange complete webinar button. And if you have any challenges, please email us at the webinar portal. Otherwise, I'm just going to say thanks. Thanks so much. And the recording will be available at the same link that you joined this at within the next couple of days. So thanks so much, Bruce. Thanks so much.
Thank you.
Thanks, Bruce. Great job.
Thank you. Appreciate the opportunity. Appreciate the invite. Look forward to seeing everybody again.